This is test ID number 31, component ID number 80. It's for the upstream or fuel control oxygen sensor. It's the half cycle count. Now 80 indicates we have a minimum spec on TID 31. It applies to the right or the rear sensor when dual sensors are used to manage fuel control. Now the PCM counts the number of times the voltage reaches 0.8 volts, which is one half cycle, and 0.2 volts, which is a second half cycle. So it's counting the tops and bottoms. That's a little bit different. This is a big improvement over older scan data readings like GM cross counts, where the PCM counted every crossing of the 0.45 volt threshold. Now, the PCM counts every crossing of either 0.8 or 0.2, remember. Now, low counts may indicate that the signal does not cross both thresholds. If it's biased one way or the other, it may only cross the 0.8 if it's biased rich, or it may only cross the 0.2 if it's biased lean. And poor fuel control may also cause the counts to be low. So this is really a big global thing to look at. Now here's some typical value. The monitor fails when the counts are low. Typical values: actual value 61, minimum value 45. We have plenty of room. We need to study the signal on a digital stereoscope to know the cause of any low counts and to verify the data we have in mode 6. Now you see it's moving live here so you can get a feel for what it's doing. We don't know of any other way to make the half cycle measurement other than with a scope pattern like we're looking at here. And we're going to take you beyond some basic testing to show you some things we look at doing Snap Accelerate. The reason we're doing these extra things is it helps us spot conditions that influence the counts we're going to be seeing in mode 6. Remember, just seeing the mode 6 counts doesn't clearly identify the problem. We can tell you what the PCM is measuring, but you also need to understand things that influence that measurement. Now here are the voltages that Chrysler uses. The first one is 0.8 at the top. We put a line there for you. And if you notice down at the bottom, we've added one for 0.2. Now, Chrysler does a measurement where they count the number of times the signal reaches 0.8 and 0.2, and they call that the half cycle counts. This is a big improvement over things like the old cross counts we used to see in the old days in scan data. Now, the other thing we're going to be doing here is we're going to be doing some snap acceleration. The snap acceleration will help us measure response time and the max and min voltages, and we're going to show you why they're important and the influence they have. Look at this response time here. It's really good. The red line shows you how quickly it goes up. We're also going to measure the max and min voltage because that tells us what the oxygen sensor is doing. When we go full rich, this sensor goes slightly over 1 volt. When we go full lean, it goes down to 0.1 volt. It could go to 0.20 volts in some cases. Now what this tells us, the max and min voltage gives us some clues about this sensor's ability to switch between half cycles. This particular sensor finds it easier to go high than it does to go low. Now that's a big finding. What does that tell us? Well, we have to consider everything. This sensor switches fast enough, but it may be cooler than normal. And how would we know it's cooler than normal? Well, we know about JTEC. JTEC systems have higher O2 sensor voltage when their sensor is cold. So we use all of this information in order to put together a complete picture of what we're looking at. So if we have a lower than expected counts in mode 6 for half cycle, it may be because the sensor is either biased too high and doesn't cross 0.2 frequently enough, or it's biased low and doesn't cross 0.8 fast enough. This is what we mean by saying take a look at the total system.